Hello, welcome everyone, and welcome to Tech of the Day. Today we're gonna talk about create Azure App Service and Web Apps. In this module, we will cover Azure App Service core concepts, creating app service and web app, creating background tasks by using WebJobs. So let's go. We have already discussed the topics. Lesson 1: Azure App Service core concepts. In this lesson, we will cover web apps, key features of app service web apps, app service plans, authentication and authorization, OS and running patching, inbound and outbound or IP addresses, Azure App Service hybrid connections, controlling traffic by using Azure Traffic Manager, Azure App Service local cache, app service environments. So there are a lot of topics we will cover. We will go one by one through all of them. App service. Azure App Service not only adds the power of Microsoft Azure to your application, such as security, load balancing, auto scaling, and automated management, you can also take advantage of its DevOps capabilities, such as continuous deployment from VSTS, GitHub, Docker Hub, and the other sources, and package management, staging environment, custom domain, and SSL certificates. So it comes with a big whole package of package for developers. This is really helpful. With the app service, you pay for the Azure compute resources that you use. The compute resources you use is determined by the app service plan that you run on your apps. That you run your apps on actually. Service for hosting web applications, REST APIs, and mobile backend can be developed in many languages like .NET, .NET Core, Java, Ruby, Node.js, PHP, Python, and they are scalable, they have DevOps capabilities, continuous deployment, load balancing, auto scaling, security, a lot of things. So app service are really interesting to learn. Next is web apps. Azure App Service web apps or just web apps is a service for hosting web applications, REST APIs, and mobile backends. You can develop in your favorite language, be it .NET, .NET Core, Java, Ruby, Node.js, PHP, Python, and applications run and scale with the ease on Windows-based environments. So web apps are scalable. Hosting for web applications provide a quick way to host your app in the cloud, allows you to scale your web app without being required to redesign for the scalability. It can integrate with your Visual Studio, an open platform for many different languages, near instant deployment, SSL and custom domain names available in the same tier. WebJobs provide workaround background processing for independent scaling, can scale to larger machines without redeploying applications. When you say WebJobs provide background processing for independent scaling, you use WebJobs separately. You could do it here as well, but you do it separately to avoid un, uh, some unwanted scaling, because if your web background processing is taking too long, your web app will be scaling according to that. So next is key features of app service web apps. Multiple languages and frameworks. Web app has first class support for ASP.NET, .NET Core, Java, Ruby, Node.js, PHP, Python. You can run also PowerShell and other scripts or executables as background services. You have DevOps optimization, setup continuous integration and deployment with Visual Studio Team Services, GitHub, Bitbucket, Docker Hub, or Azure Container Registry. You can promote updates through test and staging environments. Manage your apps and web apps by using Azure PowerShell or cross-platform command line CLI. So you have really big support for DevOps. Then you have global scale with high availability. Scale up or scale out manually or automatically. You have both options. Host your apps anywhere in Microsoft global data center infrastructure, and the app service SLA promises high availability. Connect them to SaaS platforms and on-premises data. Choose from more than 50 connectors for enterprise systems such as SAP, SaaS service such as Salesforce, and internet service such as Facebook. Access on-premise data using hybrid connections and Azure virtual networks. So this is really optimized and customized actually for your use. So you can connect to more than 50 connectors for your enterprise, be it SAP or it can be SAP for HANA, anything, SaaS services, Salesforce, and other internet services such as Facebook, Google, anything. So provides you lot of possibilities. Next is continuing on the same. Security and compliance. Other features from the other features, security and compliance. App service is ISO, SOC, and PSI compliant, which authenticate users with Azure Active Directory or with social login, Google, Facebook, Twitter, Microsoft. Create IP address restrictions and manage service identities. So for security and compliance perspective, it's really good. App service, it's ISO, SOC, and PSI compliant, so you don't have to worry about any compliance. And you can integrate security using Azure Active Directory or other social login like Google, Facebook, Twitter. Then you have application templates. Choose from the extensive list of application templates in Azure Marketplace such as WordPress, Joomla, Drupal. So you have already built-in templates. You can create a website using WordPress. Just type WordPress. I will show you later on how to create that. You can integrate Visual Studio, so dedicated tools in Visual Studio streamline the work of creating, deploying, and debugging. All can be done using Visual Studio, and you can integrate web apps in Visual Studio. API and mobile features. Web apps provide turnkey core support for RESTful API scenarios and simplifies mobile app scenarios by enabling authentication, offline data sync, push notifications, and more. Like so, if you want to have push notifications in your devices, you can add those devices in your push notifications, and it will handle everything. And serverless code. Run a code snippet or a script on demand without having to explicitly provision or manage infrastructure and pay only for the compute time your code actually uses. This is the best one that app service web apps could provide you, because you only pay for what you use and you don't provision resources in advance. Most important is app service plan. In app service plan, an app runs in app service plan. So your web app or app service runs in an app service plan. App service plan defines a set of compute resources for a web app to run. These compute resources are analogous to the server farm in conventional web hosting. One or more apps can be configured to run on the same computing resource or the same app service plan. When you create an app service plan in a certain region, for example West Europe, a set of compute resources is created for that plan in that region. Whatever apps you put into this app service plan run on these compute resources as defined by your app service plan. So you have your web apps, and those web apps are run in those resources in that app service plan. Multiple app service plan can exist in a single resource group, and multiple apps can exist in a single app service plan. So you understand it in detail in this one. So you have app service plan which contains multiple web apps. Simple. Because you pay for the computing resources your app service plan allocates, you can potentially save money by putting multiple apps into one app service plan. You can continue to add apps to an existing plan as long as plan has enough resources to handle the load. However, keep in mind that all the apps in the app service plan share the same compute resources. To determine whether the new app has the necessary resources, you must understand the capacity of the existing app service plan and the expected load of the new app. Overloading an app service plan can potentially cause downtime for your new and existing apps because you share the same resources. Authentication and authorization. You have built-in authentication authorization support. Azure App Service provides built-in authentication and authorization support, so you can sign in users and access data by writing minimal or no code in your web app, API, and mobile backend, and also Azure Functions. For all language frameworks, App Service makes users claim available to your code by injecting them into the request header for ASP.NET 4.6 apps. App Service populates claim principal current with the authenticated user's claims, so you can follow the standard .NET code pattern, including the authorized attribute. Similarly, for PHP apps, App Service populates the server and then remote server variable. App Service provides a built-in token store, which is a repository of tokens that are associated with the users of your app, web apps, API, or native mobile apps. When you enable authentication with any provider, this token store is immediately available for your app. If you enable application logging, you will observe authentication and authorization traces directly into your log files. If you observe an authentication error that you didn't expect, you can conveniently find all the details by examining your existing application logs. If you enable failed request tracing, you can review exactly what role the authentication and authorization module may have played in failed request. App Service uses federated identity, in which third-party identity provider manage the user identity and authentication flow for you. 5 identity providers are available by default: Azure Active Directory, which is in auth login Active Directory; Microsoft account, which is with the same Microsoft account; Facebook, Google, Twitter. When you enable authentication and authorization with one of these providers, its sign-in endpoint is available for user authentication and for validation of authentication tokens from provider. You can provide your users with any number of these sign-in options with ease. You can also integrate another identity provider for your own custom identity solution. So you have these 5 available, but you can also add your custom authentication and authorization providers. To explain this, the authentication and authorization module runs in the same sandbox as your application code. When it's enabled, every incoming HTTP request passes through it before being handled by your application code. So this module handles several things for your app, authenticates users with specified providers, validates, stores and refresh tokens, manages the authenticated sessions, injects identity information into request header. The module runs separately from your application code and is configured by using app settings. No SDK specific languages or changes to your application code are required. So I want you to look at this figure for some time and notice few things here. So you have app service front end, which will call the providers, then your web app core. So I want you to understand the flow. Okay, if you need more time, you can pause the video and look at it and understand it. OS and runtime patching. App service is platform as a service, PaaS service, which means that OS and application stacks are managed for you by Azure. You only manage your application and its data. Azure manages OS patching on 2 levels: physical server and the guest virtual machines that run on app service resources. Both are updated monthly. These updates are applied automatically in a way that guarantees high availability SLA for Azure services. New stable versions of supported language runtimes, major minor patches are periodically added to app service instances. Some updates override the existing installation, while the other installed side by side with existing versions. An override installation means that your app automatically runs on the updated runtime. A side-by-side installation means you must manually migrate your app to take advantage of new runtime. So there exist automatic updates and manual updates. Updating an app runtime using CLI. When a major or minor version is added, it is installed side by side with the existing version. You can manually upgrade your app to the new version if you configure the runtime version in a configuration file such as web.config, package.json. You need to upgrade with the same method. If you used an app service settings to configure your runtime version, you can change it in the Azure portal or by running Azure CLI command in the Cloud Shell. To update application runtime, use AZ web app configure set. So you have this command and then you say net framework version v4.7, then resource group name and the name of the app. Simply you updated your .NET Framework version. Then if it is a PHP version, then you can update the PHP version with the same configuration, resource group name and the name of the web app. If it's a Python version, you can do the same thing. If it's a Java container, you can do the same thing. You see here resource group name of the app, then you update the Java versions like Java version 1.8, Java container, Tomcat, Java container version 9.0. So simply you just have to call this command AZ web app config set. Simple. Updating app runtimes in Node.js. Web app does not have a built-in mechanism to update Node.js runtimes. Instead, you can use Azure web app config, the same, and then app settings set, because it does not have the direct update for Node.js. You have to do it this way. And then you say resource group and the name of the app, and then in settings you add website node default version 8.9.3. Application setting to version of Node.js that you wish to use. So this you use add in the app settings. I will show you how you can do it in portal as well, but this is how you can do it in using CLI. Next is inbound and outbound IP addresses. Azure App Service is multi-tenant service. Apps share network infrastructure with other apps. As a result, the inbound and outbound IP addresses of an app can be different and can even change in certain situations. Regardless of the number of scaled out instances, each app has a single inbound IP address. The inbound IP address might change when you perform one of the following actions like delete an app, delete the last app, delete an existing SSL binding, whatever. So if you delete an app and recreate it in a different resource group, you delete the last app in the resource group and region combination and recreate it, delete an existing SSL binding such as during certificate renewal. So for in that case, you can have a different inbound IP address, outbound IP addresses. Sometimes you might want a dedicated static IP address for your app. To get a static IP address, you need to configure an IP address based SSL binding. If you don't actually need SSL functionality to secure your app, you can even upload a self-signed certificate for this binding. In an IP-based SSL binding, the certificate is bound to the IP address itself. So app service provisions a static IP address to make it happen. Regardless of the number of scaled out instances, each app has a set number of outbound IP addresses at any given time. Any outbound connection from the app service app, such as backend database, uses one of the outbound addresses as the origin IP address. You can't know beforehand which IP address a given app instance will use to make the outbound connection. So your backend service must open its firewall to all the outbound IP address of your app. This is really interesting to know. The set of IP addresses for your app changes when you scale your app between the lower tiers, basic, standard, and premium V2 tiers. So outbound IP addresses can change if you change the tier of your app service. To understand outbound IP addresses, regardless of the number of scaled out instances, each app has a set number of outbound IP addresses at any given time. Any outbound connection from the app service app, such as connection to backend database, uses one of the outbound IP address as the origin IP addresses. And you can't know beforehand which IP address given app service instance will use to make the outbound connection, which we already talked about. Therefore, the backend service must open its all the firewall to open its firewall to all the outbound IP addresses of your app. So this app has two outbound IP addresses, and if this Azure SQL database wants to accept connection from this web app, it should open firewall for these two outbound IP addresses. Simple. When IP address changes, so regardless of the number of scaled out instance, each app has single inbound IP address. Clear. This inbound IP address might change when you perform a delete few actions, such as delete an app and recreate it in a different resource group. So if you delete an app and if you create it in a different resource group, which is obvious, if you delete it, you lose your inbound IP address, of course. Delete the last app in the resource group and reason combination and recreate it. If you delete an existing SSL binding, such as during certificate renewal, then also you lose your inbound IP address. The set of outbound IP address of your app changes when you scale your app between the tiers. So the outbound IP addresses only change if you change the tiers from basic, standard, and premium. To find out outbound IP addresses of your app, you can find set of all possible outbound IP addresses of your app can use regardless of the pricing tier by examining possible outbound IP address property here. So you say AZ web app show resource group and the name of the app, and then in query you say query outbound IP addresses and then output as a type of TSV. And to find out all possible IP addresses regardless of tier, AZ web app show resource group name and the name of the web app, and in the query you say possible outbound IP address. Output type TSV. Here you say just output outbound IP addresses, and here you say possible outbound IP addresses. So regardless of tiers, you can see all the possible IP addresses, and here you see the actual ones with query outbound IP addresses. Azure App Service hybrid connections. Really interesting to know. Within App Service, hybrid connections can be used to access application resources in other networks. It provides access from your app to an application endpoint. It does not enable an alternate capability to access your application. As used in App Service, each hybrid connection correlates to a single TCP host and port combination. This means that hybrid connection endpoint can be on any operating system and any application, provided you are accessing a TCP listening port. So the hybrid connection feature does not know or care what the application protocol is or what you are using. It's simply providing network access. Hybrid connections is both a service in Azure and a feature in Azure App Service as a service. It has a capability beyond those that are used in App Service. There are many benefits of hybrid connection capabilities, which are app can access on-premise system and services securely. The feature does not require an internet accessible endpoint. It is quick and easy to set up. Each hybrid connection matches to a single host port combination. So you need a host and port combination, which is helpful for security. It normally does not require firewall holes. The connections are all outbound over standard web ports. Because the feature is network level, it is agnostic to the language used by your app and the technology used by the endpoint. It can be used to provide access in multiple networks from a single app, to enable access to resource in other networks, any operating system and any application, hosted in cloud networks, local networks, or even a specific machine. And it can correlate to single TCP host and port combination. So Azure App Service hybrid connection is really beneficial when you want to connect with your on-premises resources. For an example, to see app service hybrid connection with your app, hybrid connection feature consists of two outbound calls to Azure App Service bus relay. There is a connection from library on the host where your app is running in app service. There is also a connection from hybrid connection manager to service bus relay. So you have a hybrid connection manager to service bus relay. The hybrid connection manager, or HCM, is a relay service that you deploy within the network hosting the resource that you are trying to access. So in the same network hosting, you have a HCM. Through the two joined connections, your app has TCP tunnel to a fixed host port combination. On the other side of the HCM, the connection uses TLS 1.2 for security and shared access signature keys for authentication and authorization. When your app makes a DNS request that matches a configured hybrid connection endpoint, the outbound TCP traffic will be redirected through the hybrid connection. Now you need to control traffic using Azure Traffic Manager. You can use Azure Traffic Manager to control how requests from web clients are distributed to apps in your Azure App Service. When App Service endpoints are added to an Azure Traffic Manager profile, Azure Traffic Manager keeps track of status of your app service running, stopped, or deleted, so that it can decide which of those endpoints should receive traffic. So you can configure, and then it keep watching the status of your app service, and it can redirect to which endpoint it should send the traffic to. To configure the control of app service app traffic, you create a profile in Azure Traffic Manager and then add the endpoints for which you want to control traffic to the profile. Your app status, then, if it's running, stopped, or deleted, is regularly communicated to the profile so that Azure Traffic Manager can redirect the traffic accordingly. So it's really useful to keep watching your app. So to see an example here, you can use Azure Traffic Manager to control how requests from web clients are distributed to apps in Azure App Service. Traffic Manager uses DNS to direct client requests to most appropriate service endpoints based on a traffic routing method and health of the endpoints, which we just talked about. So you have an inbound IP address, and then Azure Traffic Manager. Using the DNS, it can redirect you to the correct IP address, to correct endpoint. So what are the Azure Traffic Manager routing methods. There are four: priority, weighted, performance, and geographic. Priority: use a primary app for all traffic and provide backups in case primary or backup apps are unavailable. So you have an priority app and it redirects the traffic and provide backup if the primary app is unavailable. You have weighted, so you distribute traffic across a set of apps either evenly or according to weights which you define. So let's say you want to distribute the traffic according all over the apps instances evenly, then you can do so. Performance: when you have apps in different geographic locations, use the closest app in terms of lowest network latency. So for lowest network latency, you use the performance. Geographic: direct users to specific apps based on which geographic location their DNS query originated from, which is also interesting. Then you have priority traffic routing method. For the priority traffic routing method, you often an organization wants to provide reliability for its services by deploying one or more backup services in their primary service. When their primary service goes down, the priority traffic routing method allows Azure customers to easily implement this failover pattern. The Azure Traffic Manager profile contains a prioritized list of service endpoints. By default, Traffic Manager sends all traffic to the primary or highest priority endpoint. If the primary endpoint is not available, traffic routes the traffic to the second endpoint, and so on. So you have here endpoints with the priority, and if it's degraded, then failover is second priority, so it will go to this one, and if this is failover, then the third one. So you have browser coming here and DNS, recursive DNS, and then traffic manager. So the user makes a request, and using the DNS it comes to traffic manager. Traffic manager sends and health check and see if the primary service is unavailable, then it will send it to second endpoint. For the weighted traffic manager routing, you have you give some weight to the applications. So you see here, if the first primary with 50 weight is degraded, then it will go to the failover B, which is with the weight 50, and if in the end it will go to the failover A. For each DNS query received, Traffic Manager randomly chooses an available endpoint. The probability of choosing an endpoint is based on the weight assigned to all available endpoints. Using the same weight across all endpoints results in an even traffic distribution. So using higher or lower weights on specific endpoints causes those endpoints to be returned frequently in DNS response. So if you want to divide the traffic evenly, then you need to give weights evenly. Then according to the performance, it has Azure Traffic Manager contains the IP range and the region and the performance latency, and then accordingly it decides which endpoint it should send it to. So if you are in North Europe, then it will redirect you to endpoint 2, because it contains according to the endpoint, it contains the latency. Geographic traffic routing method, which is different. So don't get confused with performance traffic and geographic, because with performance it checks how much time it takes for certain regions, and here it is decided if you are in Germany, then endpoint 1 will be used, and if you are in Mexico, then nested profile priority endpoint will be used, endpoint A and endpoint B. So this is based on geography. Azure App Service Local Cache. Azure Web App content is stored on Azure storage and is surfaced up in durable manner as content share. This design is intended to work with a variety of apps and has the following attributes, like the content is shared across multiple virtual machine instances of the web app. The content is durable and can be modified by running web apps. Log files and diagnostic data files are available under the same shared content folder. Publishing new content directly updates the content folder. You can immediately view the same content through the SCM website and run the running web app. Typically, some technologies such as ASP.NET to initiate a web app restart on some file changes to get the latest content. While many web apps are use one of all these features, some web apps just need a high performance read only content stored that they can run from with high availability. These apps can benefit from VM instance of specific local cache. The Azure App Service local cache feature provide a web role view of your content. This content is write but discard cache of your storage content that is created asynchronously on site startup. When the cache is ready, the site is switched to run against the cached content. Web apps that run on local cache have many benefits, like they are immune to latency that occur when they access content on Azure storage. They are minimum they are immune to the planned upgrades or unplanned downtimes and any other disruption with Azure storage that occur on servers that serve the content share. They have fewer app restarts due to storage share changes. App service environments. The content is shared across multiple virtual machine instances of the web app. The content is durable. So app service environment is an Azure App Service feature that provides a fully isolated and dedicated environment for securely running app service apps at high scale. App service environments are appropriate for application workloads that require very high scale, isolation and secure network access, high memory utilization. Customer can create multiple app service environments within a single Azure region or across multiple Azure regions. This flexibility makes app service environments ideal for horizontally scaling stateless applications in support of high remote PowerShell workloads. ASE are isolated to running only a single customer's application and are always deployed into virtual network. Customers have fine-grained control over inbound and outbound network traffic. Applications can establish high-speed secure connection over virtual private network or VPN to on-premise corporate resources, and ASE is dedicated exclusively to a single subscription and can host 100 app service plan instances. The range can span 100 instances in a single app service plan to 100 single instances app service plans, and everything in between. An ASE is composed of front-end and workers. Front-end are responsible for HTTP, HTTPS termination, and automatic load balancing of app requests within an ASE. Front ends are automatically added as the app service plan in ASE are scaled out. So it's clear. Next, lesson 2, creating Azure App Service web app. In this lesson, we will be creating web app with Azure CLI. We will be creating Azure web app with Azure PowerShell and app service on Linux. Creating a web app with Azure CLI. So to generate a random web app name, then we need to create a resource group name, resource group. Then we create a new app service plan using the randomly generated web app name as the name of the plan and the free tier. And then you create a new web app using app service plan created just this step before this step and the randomly generated name. So you just create a web app name, then you create a AZ web app is a resource group name, then you create an app service plan, and then you create the web app. Simple. And to deploy a web app with Azure CLI, so let's say we store a GitHub URL. So you store your repository on GitHub. You have, let's say, this example, store a repository URL as a shelf variable. You have that in Azure samples on GitHub, and then you want to deploy this code from this Git repository to the web app. Then you say deployment source config, the name of the web app we just created, resource group name, and the repo URL at git repo, and the branch you say master, and you say manual integration. So to see if you have perfectly deployed your app or not, then you to print out the SQDN of your web app, use print echo this printout. To get more familiar with Azure PowerShell, you have these commands, and it's the same thing. So you say command new Azure RM resource groups, which creates a resource group in all resources. To create an app service plan, you say new Azure RM app service plan, which creates app service plan, and then to create new web app, you say new Azure RM web app, and to modify a resource in resource group, you just say set Azure RM resource. To create a Azure PowerShell, to create an app service plan with Azure PowerShell, you generate a random web app name and variables for the location and repository URL. Then you create a resource group, and then you create a new app service plan by using randomly generated web app name as the name of the plan and the free tier. So you say git repo is this one, web app name just is generated randomly. You say location West Europe, and now you create a new resource group by saying new Azure RM resource group, and name is my resource group. location, my location. And to create a new app service plan, you say new Azure RM app service plan, name, web app name, location, resource group name, my resource group, and tier is free. Easy. And to create a web app in Azure PowerShell, you say create a new web app by using app service plan created earlier and randomly generated name. Then you deploy the code from public URL using master branch to the web app created earlier. So new Azure RM web app with the name, location, app service plan we just created, and resource group name we just created. So you just say create a new web app and create a deployment resource manually using ARM template with properties object repo URL which you have provided earlier. Branch master is manual integration true. Then you set Azure RM resource, which is property object, resource group name, resource type, Microsoft.website.source controls, and resource name is web app name, and then web with the API version is you can put any version with force. So what we are doing here, simply setting the resource with property object which we created recently using ARM template, and my resource group. In the resource group, resource type is Microsoft.website as with the source controls, and resource name is this. It looks a bit complicated, but I want you to look at this for some moment and memorize it and remember it. It's really interesting to know, but you also have questions related to this in your exam, so just memorize it and understand it a little bit more. You just need to, if you need to give more time, you just pause it and do some exercise as well. Create app service on Linux. App Service is a fully managed compute platform that is optimized for hosting website and web applications. App Service on Linux provide a high scalable, self-patching web hosting service by using Linux operating system. Customers can use App Service on Linux to host web apps natively on Linux for supported application stack. And Docker comes in existence when you have App Service on Linux. App Service Linux provide predefined application stack on Linux with supported for languages such as .NET, PHP, Node.js, and others. These application stacks are defined by using Docker containers. You can also use a custom Docker image to run your web app on an application stack that is not already defined in Azure. So using a Docker container for app service can ensure that your applications remain portable and work in all your environments. So what you do, you for Linux, you get the Docker container image, and or you can have the available one, or you can create your own custom Docker image, and then you use it to run your .NET app service, sorry, not .NET, but any app service on Linux environment, and deploy it. Same way, web apps for Linux containers. Web app for containers provide built-in Docker image on Linux with support for specific versions such as PHP or Node.js, with specific versions of PHP and let's say PHP 7.0 or Node.js 4.5. Web app for containers uses the Docker container technology to host both built-in images and custom images as platform as a service. And this is compatible with existing app service features such as auto-scale, deployment slots, and others. You have CI/CD, Docker Hub, Azure Container Registry, and GitHub. Simplifies the deployment also. So it's almost the same except the fact that you have them in on Docker image for Linux. Custom image development requires basic knowledge of the Docker development workflow. Deployment of a custom image to web app requires publication of your custom image to repository hosts like Docker Hub. So if you have a custom image, then you need to deploy it to uh, repository host, and then you can use that custom image in your Azure environment. If you are familiar with Docker and can add Docker tasks to your build workflow, or if you are already publishing your apps as Docker image, a custom image is almost certainly the best choice. So this is basically for those who were habitual or who were working already with Docker containers and Docker images and hosting their applications using that, so they can simply switch to Azure. Now the lesson 3 is creating background tasks by using WebJobs. In this lesson we will cover WebJobs, creating continuous WebJobs, and creating triggered WebJobs. WebJob is a feature of Azure App Service that enables you to run a program or a script in the same context as a web app, API app, or mobile app. There is no additional cost to use WebJobs. The Azure WebJobs SDK can be used with WebJobs to simplify many programming tasks. So it supports the program or scripts with .cmd, .bat, .exe, .ps1, .sh, .php, .py, .js, .jar files. So it supports almost all the programming languages executable files. It runs background tasks and scripts within the same application context as your apps. Doesn't incur additional cost and doesn't require new resources. And it's the built-in feature of app service. So for the web job types, you have continuous and you have triggered. Continuous starts immediately when web job is created. To keep the job from ending, the program or a script typically does its work inside an endless loop. If job does end, you can restart it. Runs on all instances that the web apps runs on. You can optionally restrict the web job to a single instance. It supports remote debugging. And then there is triggered. For the triggered, starts when only triggered manually or on a scheduled basis, runs on a single instance that Azure selects for load balancing, does not support remote debugging. The continuous supports remote debugging, but trigger does not. A web app can time out after 20 minutes of inactivity. Only requests to the SCM deployment site or the web apps pages in the portal reset the timer. A request to the actual site doesn't reset the timer. If your app runs continuous or scheduled web jobs, enable always on to ensure that the web jobs run reliably. This feature is available in basic, standard, and premium pricing tiers only. To create a web job, you simply need to give a name, and then you upload the .exe file in zip fun, and you say the time type and the scale. You need to say what type of scaling you want. The file upload field requires a zip file that contains your executable or a script file and any supporting files needed to run the program or script. So basically, this is your program. It can be a console application containing all the resources it needs to run. The multi-instance scale option is available only for continuous web jobs. This option determines whether the program or script runs on all instances or just one instance. The option to run on multiple instances doesn't apply to the free or shared pricing tiers. I'm not going to do this on my Azure portal because I don't have any program, any console application done or zipped. I have actually. It's not a big deal to create one, but it's simple, so it's kind of wasting time. Next is creating triggered web jobs. It's the same, except the fact that you change the type and triggers. Then if you change the type to triggered, it will ask you for the manual. So file upload is the same, and after you select the trigger type option, the skill option is disabled, and in the triggers field you can select a manual trigger or scheduled trigger. So you can say you can schedule a trigger or you can manually trigger it. Let's do a demo where we will create a continuous web job that is scaled to multiple instances of our web app, and will also create a manually triggered web job. So I am in my resource. Create a web job. Of course, we need a web app. So I'm creating a web app here. Okay. Okay, I don't care. But I didn't want to give the name like this. Anyway, it's okay. Now you see your web app name should be unique all over the Azure websites.net. So I should say AZ-203. I don't know. I don't think it's available. Web app. Oh, it's available. But not app, I guess. Yeah, app is not available. But let's say Nitesh. It should be available. Okay. Then I say the type, if it's from the Docker container or from the code, and to publish, and the runtime stack. Which runtime stack I want to use? I want to use .NET Core, and which is, let's say, .NET Core 3.1. Operating system Windows automatically selected, because and the region is Central US. It automatically creates a new service plan for app service plan for me, but I can change it, of course, because in using the one we just created using CLI, we created the app service plan before creating the web app, but here it's just suggesting us, so I can change the size and choose the cheaper one. I am in dev, then I can have the free tier, which is shared infrastructure, 1 GB of memory, 60 minutes per day compute. This is only for development purpose. If you need it for more, then you can see here what is included in this one. If I change to another one, just shared infrastructure, which adds custom domain service for me as well. And if I go a bit further, then it adds storage, 10 GB of storage, disk storage, and it can have a manual scaling. So to decide which one to use, you need to see what you need in your application. If you need automatic scaling, then you cannot use the dev test one. You have to go to production and then select any of them. Let's say first one, then you have auto scaling up to 10 instances, staging slots, daily backups, traffic manager. So to see what features you need to then you need to change your type of spec. So let's say I choose this one, apply. So I have the SKU and size for my web app for this one, and then I go further. I don't want application inside, but it's by default adding it. Anyway, it's good to have application inside. I don't think I will have any tag, so I will go with the review and create. So I'm just creating now my web app. It's validated, I guess. Okay, create. Deployment is underway. No result yet. Ready? So if you go to resource, to see this web app, it just gives you the information about it, and here you can access your web app. Sorry. With this web URL, you can go there. It has nothing because I didn't put anything here yet. But you will have this default web app here. It says talk about my app service plan. It has its own FTP hostname and HTTPS hostname, but it is not enabled yet. That means there is no user, so that you cannot use using FTP. You don't really have any information yet here. So in here, if you go through access control IAM, you can add role-based assignment to your web app, and you can say what type of role you want to give. If you want to give a role, contributor role using your Azure Active Directory or Service Principal, or you want to assign to a managed identity, which you need to create first. And if you select this one, then it will say or tell you about the email address or already existing ones. You can say app service, and then you can allow another app service to connect to it. You can add other function app, data factory, container registry, container instance. So it can be anything. You need to discard. Then if you want to check the security, it just tells you about the recommendations you can have about the security patches you need to do. Okay, and then authentication and authorization we already talked about. You can add authentication and authorization for your app. Currently, it's anonymous access enabled for your app, but you can say on, and then you need to allow and you need to add provider, authentication provider. But interesting thing about it is you don't need to add this in your application. It will be automatically added. So if someone tries to go to your app, it will try to authenticate you with these things. I say off and I don't need to configure it. If I say on, then I need to configure, and then I will say authentication provider Azure Active Directory. And now my web app is saved with authentication. Let me just if I try to access it here, it goes there. If I go to this app here, okay, it will take some time to take authentication in place, but it will not be available for me after some time. Identity. I can have system assigned or user assigned identities, and I can add them here. User assigned identity, I can simply add another user assigned identity here, and that can access my app directly. Backup, custom TLS, SSL settings, and scale up, scale out. You need to do if you want your application to be scale up automatically, then you can simply select it. And if you want to do manually scale out, so you say manual, but you can say custom auto scale, and then you can set the auto scale parameters for your application. So it's very interesting, easy to do, easy to implement. And then here comes WebJobs, which we wanted to do. So there is no web job for the moment, but you can add one web job. It's simple with the name my web job 01. I need to upload the file, and then I need to say the type. So if it's a continuous, it will say multi-instance. If it's triggered, then it will ask me to schedule it if I want it to be scheduled, and I can say manual. Then I don't need to schedule it. But if I want to schedule it, then I can say cron expression. Provide a valid cron to define your schedule. So you can schedule your app, but I'm not going to do it now because it doesn't make sense for me to do any. I don't have any application, but it's easy. I guess you understood. And now I have my web app running up and running here. If I just simply change the code here, I will have my own application, which is simple. You have this deployment slot, which is also interesting. Are live apps with their own host names. App content and configuration elements can be swapped between two deployments. So if you say, and now you create another deployment slot, and I'm just cloning my existing existing app. It's very interesting to know, actually. It's very interesting to use them, because if you are having two different slots, and you need to test your application before going to production, you need to have, let's say, staging, pre-production and production, and then you say if your pre-production is working, then you can switch from production to pre-production. Let me show you. It's really interesting to do. So here you have the first one running, and then you have the test, and the traffic to the first one is 100. So if you change the traffic to the second one, and let's say 80, so the traffic to the first one becomes 20. It's really interesting to do. And then if you say 100, then your traffic becomes, the first one becomes 0. And then you have your app here. It's running here. Same app is available here with the different URL. You have added test. Interesting thing is, now what you see here as option is swap. So if you just want to swap your test application code with the production code, then your production code will have same as test. So if you just swap, it will show you what changes you have in both applications, and then it will show you. So here we don't have any change on this application, but if we had, let's say, in test we have something different here, and production we didn't have that. So let's say if it was a pre-production environment, we just can build it and swap it. It will take, of course it will take some time. So what we did, we simply swapped the test one with the production one, and let's see what happens. There won't be many changes, or any change actually. There should not be any change, because I did not have any unsafe changes will be discarded. Successfully completed swap between slot test and slot production. So now your slots are swapped, so your your application is exchanged with this one. If you just close it, we go back to slots. Now your production has the code from test, and test has code from production. We don't have any change here, but if we had, then it should have interchanged as well. That's very interesting for the continuous delivery and deployment, and then you can simply switch your app really easy. And I am just saving my changes. I can go back now. So what we learned today, we created a web app and we created WebJobs using Azure portal. We created Azure App Service core concepts. We learned about Azure App Service core concepts. We created Azure App Service web app. We created background web jobs in Azure portal. We also created web apps using Azure CLI. We also created web apps using Azure PowerShell. So I hope you liked it, and thank you for watching. Please like, share, and subscribe. Thank you. Stay in touch, and good luck for your certifications. Thank you. Bye.